EMFs, how do they cause biological damage and even cancer? Hi, this is Dr. Mercola, helping you take control of your health. And today we are joined by a researcher, Dr. Paul Heroux, who's a professor at McGill University in Montreal in the Faculty of Medicine. And he is going to help us answer that question because he's done some really interesting research to elucidate the mechanism. So welcome, and thank you for joining us today.
Thank you very much.
So to provide our viewers with a bit of your background, I thought it'd be best if you would elaborate on it and how you first became interested in this field and what your primary focus is now.
Well, at some time, I was trained as a physicist, and eventually I gravitated to a power utility and did a PhD there on electrical power transmission lines. And in the course of working for the power utility, I got interested in the health effects of power lines associated with their fields, and I found that extremely interesting. I got involved into biology, followed courses in medicine, and became a, so to speak, a type of different person from what my supervisors initially would have expected me to be. So that made life very interesting and somewhat difficult, but I became a specialist on the effects of magnetic fields on the human body over time, and eventually I went to the Faculty of Medicine to try to protect health and the environment.
Okay, good. So before we go into more specific details, I think it would be best if you could help us understand from your perspective the different types of electromagnetic fields. You know, basically broadly there's electric, magnetic as you referenced and is one of your focuses, and then of course radio frequency. So perhaps you can expand on that, and then we'll delve into the focus on the magnetic component.
Yes, even if you look at the literature, what you will find is that it tends to discriminate a lot between, say, low frequency fields and high frequency fields and microwaves and electric fields and magnetic fields. But actually, all of these fields have a lot in common. And in a sense, you can practically lump all of them in terms of their biological action, in the sense that it's true that frequency influences the effects, but basically they all proceed the fields by the same mechanisms. In other words, I could, using an electric field or a magnetic field, produce the same effect in a cell. And most higher frequency signals have enough low frequency components to have a lot in common with low frequency components. So the practical aspect of this is that usually the fields have an effect maybe in one application, but they are mirrored in other applications as well. So there's a type of great unifying view that you can have about these fields.
Yes, indeed. And I'm sure you're familiar with Dr. Martin Paul's work, who's an investigator who also had interviewed previously. And he published a paper in 2013, but I think your work precedes his. But he essentially elucidated his version of the mechanisms, which is the voltage-gated calcium channels. But in that mechanism, he said exactly what you did, in that it's pretty much all of the fields work through the same mechanism. They cause the same biological damage. So before we go into specific details, I'm wondering if you could give us your perspective and explanation of the fact that this damage, and you and I both strongly believe that there's major damage of being exposed to excessive fields, is not due to thermal injury, which is what the experts in the field would have us believe. It's due to non-thermal mechanisms, and that's what Dr. Paul's described, and you have your version of what the mechanisms. So can you elaborate on the non-thermal mechanisms?
Yes. It's obvious that if you cook something, there has been a drastic effect. And industry was very, I would say, enthusiastic about jumping on this concept, because they knew that if they promoted the existence of these thermal effects and, so to speak, highlighted them, this would result in standards of exposure that would give them a free hand to develop any application that they wanted. So to them, it was very, very important to promote that idea. But I would say that really industry has no interest in uncovering the effects of electromagnetic fields. Its interest is in protecting their product. So whenever a scientist would come up with a non-thermal effect, industry, so to speak, specialists or more likely henchmen would find always something wrong with it. It could never be included for protection of the public. It was too vague. There was always something wrong with it, which really shows that if you don't want to see something, there are none so blind as those who will not see. So there have been hundreds of researchers who have seen the effects both at low frequencies and at high frequencies. So covering the whole spectrum, there is no doubt that there are biological effects. And furthermore, I would add, there is no doubt that there are substantial health effects that we have been experiencing for a long time and that have been increasing our health bills.
Well, thank you, and I couldn't agree more. And in fact, this is not a novel and new strategy. They've copied the book or the playbook from the tobacco industry, and I think it would be fair to say that cell phones being a metaphor for all of EMF, are the new cigarettes, essentially, because the tobacco industry used the same strategies, which is what you just described, that anyone who seeks to expose the truth, whether it's a journalist or a researcher, is first of all discredited. And then secondly, if they're researchers particularly, they are defunded. All their funding is removed. And then after that, people on their payroll, typically other scientists, that radically outnumber that researcher, maybe 10 or 20 different scientists will be funded to publish opposing views that support the industry's interest. So this is a strategy that is well recognized with tobacco and big pharma, but many people don't understand that this is also going on in the telecommunications industry.
Yes, you are right. And I've seen personally many examples of something like this. And the simplest thing to do for industry is to make sure that no money is put into research. And also one of their strategies is to patiently put people on committees. And usually the people that they promote as experts are individuals who don't really have direct experience of biology or medicine themselves. There are people who've read a lot of industry slanted documents and so are able to present a view of science that is a bit distorted.
Okay, well, thank you. Now that we have laid a foundational background as to the reasons why many people may not be aware of the concerns that are here because they believe the public health authorities and essentially the industry-funded researchers, let's lay the groundwork for what you've been doing for the last few decades with respect to applying your relatively novel combination of physics and biology to help us understand the biological damage that's occurring from exposure to these fields. So why don't you walk us through your journey of when you first started working with the power companies and what your observations were and what you discovered?
Okay, so initially I got into this field because a power utility asked me to design an instrument that would measure electromagnetic fields on workers. And so I designed a dosimeter that was a very successful unit. And after that, I imagined that maybe this would be followed up with basic work on the biology of the phenomenon, but obviously the utility was not very interested in that. Essentially, about at that time, I went to McGill University at the Faculty of Medicine and started to do research. And I had a student in the lab who was working on the toxicity of metals, who came to me one day and said, why don't you give me a subject that would be a little more spectacular than the toxicity of metals, which is something that is a bit humdrum for me. So I said, if you're willing to take risks, we can go there. And this student, this girl, started to work on magnetic fields. And the results that came up and out of these experiments were quite spectacular. The effects were very, very strong. And from then on, I felt that I could not ignore this and that I had to bring this to the attention of the world. Essentially, what we found is that very small levels of magnetic fields, say at 60 hertz, the power frequency, can have very, very drastic effects on cancer cells in culture. And it's not that the effect is hard to see. It's extremely easy to see. And that explains why 90% of people who run experiments like this see corresponding effects. Now, as far as I'm concerned, the biggest drama is that when these problems were even mentioned in the literature, many biologists tackled this problem, and within a few years, the answers were found. But the answers were never acknowledged. Saunders at Duke University in 1985 published an article that showed very clearly that these fields were able to suppress metabolism. And years later, in the early 2000s, I found exactly the same thing, adding a few details that explained how physically this happened. But the true answers were found very, very quickly, but simply ignored and not acknowledged by industry in particular.
So this information has essentially been suppressed, radically suppressed, and replaced with the propaganda that the industry wants us to hear so they could sell more of their product.
It's essentially, that's the take-home message. You can put in a bibliography that you will then afterwards supply for free to government organizations, the articles that you want. You can filter in the ones that are favorable to your product and filter out the ones that you don't like for all sorts of pretexts and reasons. And this is in great part the mechanism that has been used by industry, providing services free of charge on committees, providing bibliography reviews that are slanted at no cost to organizations that don't have the means to do that really independently.
Okay. Well, let's dive a little deeper in your initial findings and observations and why you've been focusing on magnetic fields. So your initial research was on magnetic fields from the 60 hertz AC power supply. So would that mean that the magnetic fields were also pulsed at 60 hertz, or were they static?
No, they were continuous sine wave oscillations at 60 hertz. But what I did that was a bit unusual is that I took great care to eliminate all environmental fields from the experiments, because as you know, in a cell incubator, you are likely to encounter fairly strong magnetic fields as a result of the heating, of the electronics, and of the ventilator at the top of the unit. So I had to put in around each cell culture 1 inch of steel, essentially shaped as a cylinder, in order to eliminate these external fields and then add the fields that I wanted to study. And under these good conditions, with cell cultures that were extremely tightly controlled, the effects of magnetic fields became entirely clear and very, very spectacular. So I knew that there was something important happening.
And maybe we can just go into the details of what effects you observed. I believe that was the chromosome damage. And can you elaborate on that and how you determined it and what level of fields produced these effects?
Okay, so we, of course, studied the cross frequency and the cross intensity. And we found that at levels of around 20 nanotesla, which is 0.02 microtesla, the effect started, was fully developed around 50 nanotesla, and I'm talking here for a field of 60 hertz. So those are fields in which you are about 50% of the time. And
Let's stop there, because most people, with if they were aware of magnetic fields and measuring them, they're using milligauss. So would the microtesla be equivalent to a milligauss?
1 microtesla is 10 milligauss.
Okay, so it's up by a factor of 10. Okay.
Yes. So, but the fields I'm talking about that had these very big effects on cells are fields that you're exposed to and that you go in and out of every day. They are environmental fields. You find a lot of literature where people apply astronomical levels of fields to biological systems. But what I found is that at environmental levels, you have very strong effects. And
let's stop there again, because you're saying we go in and out of these fields, but from the measurements I've done and the levels you're describing, I would venture to say that the vast majority, maybe over 90% of them, never leave these fields. They're in them all, that's continuously. They don't go out. They're not sleeping in an environment or even working in one, because it's hard. And if you're in an electrified home, it's just really hard to get low fields.
But if you go away from all appliances and you go in your backyard and so on and so forth, then you will be in fields that are lower than those. But you're right. Those levels are low enough that we are subjected to them a large proportion of the time. So even walking the streets, you will be in and out of these fields, even out of your home and in an area that's practically unencumbered.
Let's go back to your earlier comment that you said pretty much all the fields work similarly on biological mechanisms. So say you go outside and you're able to get a low magnetic field, you're still going to be exposed to the high frequency fields of microwaves and cell phone radiation, because the towers are pervasive, and it's very, very difficult to avoid them in any urban area, and even in most rural areas. That exposure outside, even though you have low magnetic fields, may be unmeasurable, cause the same process problems, because it's a similar pathology, similar mechanism.
Yes, this is true. And unfortunately, our environment is essentially being filled to the hilt with these disturbances of our metabolism. And from the point of view of industry, this is wonderful, because this contamination being evenly spread and present everywhere, this becomes the new normal. In other words, if you don't want to be caught intoxicating a population, expose them all at the same time so that there is no reference population. And of course, cell phones in particular are so popular that they have essentially achieved this, a rapid ride and exposure practically everywhere.
Yes, indeed. And you're right, there is no reference population anymore. There did exist one about 70 years ago, about a century, about 100 years ago to 70 years ago, was the electrification of most of the world, certainly in the United States, where from 1900 to 1950, most of the rural areas were not electrified. So, Sam Milham, who I've also interviewed, did some amazing investigative epidemiological work that showed radical differences in the incidence of almost every major disease between the rural population and the urban population between 1900 and 1950. And then once that rural population became electrified, those disease rates converged to the point now where they're the same.
I strongly believe that to be one of the most important observations of this century. The fact that we have modified our environment willingly, and that we have integrated these negative health impacts without officially noticing them.
Yeah, well, some people have, but Milham has, of course, been discredited and suppressed, and industry wants to shut him up big time. And certainly he's getting on in age; he's in his 80s now. But he did some. It was incredible pioneering work in the last century. So let's expand now a bit on yours, because I'm really intrigued with the mechanism of action, And maybe you can describe how this magnetic field, or at least your speculated proposed mechanism is with the production of energy through ATP and ATP
Okay.
synthetase specifically.
Yes. So this enzyme, is ATP synthase, looks exactly like an electrical motor. In other
Mhm.
words, it passes currents of protons through what is not a wire, but it's a water wire, a channel. And that's fairly long in terms, the protons have to go through about 20 molecules of water through this channel. Now, water fundamentally is not very, very conductive electrically. But this molecule, ATP synthase, which is extremely ancient, common to all living systems, functions and creates mechanical work, rotation, that is
Mhm.
used to generate ATP from ADP using this flow of protons. And at the very basic level, what magnetic fields can do is that they can change the transparency of the water channel to protons. Currents are reduced and you have less ATP. Now, the cell is extremely adept at, uh, I would say, at compensating for this because a cell cannot run out of ATP. So there's
Mhm.
this other enzyme, adenosine monophosphate protein kinase alpha,
Mhm.
which controls all the processes of the cell to compensate for the action of the field. And
Mhm.
so, in essence, in a very superficial way, you could say that, oh, there's not much happening. But when you impair the flow of protons through ATP synthase, what you do is that you increase what is called mitochondrial membrane polarization
Mhm.
because you're essentially blocking a process of trickling of protons through the enzyme. If you increase the polarization of the mitochondria by 14%, you will have a 70% increase in reactive oxygen species coming out of complex 1, which
Mm.
is the leading edge of the oxidative phosphorylation
Mhm.
chain. So essentially, my explanation is that by physical action on water, you can change the transparency of the most critical enzyme in the human body, modulate the amount of ATP,
Mhm.
increase essentially the escape of electrons from complex 1, thereby explaining practically all of the observations related to EMF. And of course, the moment ATP is perturbed in a cell, there's calcium signals being emitted all over the place because calcium is
Mhm.
possibly the most critical intracellular messenger.
Yes, yeah. So in many ways, that lines up precisely with Martin Paul's work, which I'm sure you're familiar with, and maybe you can integrate those. And but before we dive deep there, just a little background of for those who haven't studied mitochondria, but uh, the mitochondria, of course, are the energy producers in the body. They create the current and the energy that we require. But embedded in these mitochondrial membranes, the intermitochondrial membrane, are these electron transport chains. And the first one is the one you're referring to that causes all this damage. And I wasn't aware that there was such a massive increase if you depolarize the cell membranes. I mean, but essentially that seems to be the mechanism, is this excess oxidative stress, which Martin Paul says is the same thing. Ultimately, his belief is that it's activation of the voltage gated calcium channels, which releases high amounts of intracellular calcium that causes this, or catalyzes this domino effect of increased oxidative stress. So can you reconcile his work and yours? And it seems like there's a synergy there, and they're complementary because they're essentially the same end result, but a little bit different mechanism.
Yeah, you're right. The mechanisms are different because at some point in time, the Bioelectromagnetic Society had a lot of annual meetings where the capability of, say, magnetic fields to influence channels, for example, voltage sensitive channels, was investigated in detail. And if you know Abraham Leboff, he had his cyclotron resonance theory that was also, I would say, close to these investigations. But the truth is that from the physics point of view, it's very hard to explain how such low fields can actually alter the behavior of these channels. And it's also hard to explain how such low fields can alter the behavior of calcium ions in solution. And for me, the answer is that it's not calcium ions on which you're acting directly. What you're acting on are electrons and protons that are a lot more sensitive to fields. And because oxidative phosphorylation depends on the flow of electrons and protons, you have a very, very exquisite sensitivity to very low field levels of biological systems. And when I talk about biological systems, it's not humans only. It's insects, it's vegetation. All living systems depend on ATP synthase.
Yeah, and so it's our gut microbes too, which is frequently overlooked.
Yes. So basically, fields act on the ability of protons to move from one molecule of water to another, in the case of ATP synthase. And also, they alter the probability that an electron within a single molecule even can jump from one position to another. So this is the only, I would say, physical mechanism that can explain the observations of people like Belayev, who show that you have reproducible effects of fields at extraordinarily low levels. You have free electrons and free protons. And the reasons why these particles are free is that they function in biological system through a process called tunneling. And when a particle tunnels from one atom to another, in other words, either an electron or a proton tunnels from one molecule to another, it is vulnerable to vanishingly small fields. In other words, tunneling can be what we call in physics adiabatic. In other words, requires no energy. So to influence this flow of charges, you don't need to break molecules, as industry claims. All you have to do is to have a field that can alter their probability of jumping from one position to another.
But isn't ultimately the end biological result an increase in oxidative stress? And this oxidative stress is actually what causes the damage of breaking the bonds in the DNA, the cell membranes, and the proteins. It's not the energy in the electromagnetic frequency that catalyzed the process, but it's a secondary damage from the oxidative stress. That was my understanding. I thought that's what you were saying too, but is that not correct?
Yes. The energy of the field itself is irrelevant in a sense. So the idea that you have to reach ionization potential in order to create
like an
damage,
X-ray or gamma ray, right?
Yes, is totally wrong. So you create damage because you're leaking electrons from the oxidative phosphorylation chain, but perhaps more significantly, by altering metabolism and the production of ATP, you are confusing the programming of metabolism that has been developed over the last 2 billion years. Our species can evolve and is successful in great part because we were successful at generating large amounts of ATP. If you touch that, you're going to have disturbances of metabolism that will occur over chronic exposure that will result in increases in the rate of diabetes. And that is probably true for all types of electromagnetic radiation, be it power frequency, be it AM, FM, be it television signals. All of these have in common the property that they have fields that can affect these charges. So the view that these electromagnetic fields are innocuous to biological systems is simply plainly wrong.
All right, I want to jump back to your mechanism again because there's a bit of an area of confusion. When you stated that when the ATP synthase is exposed to these fields, it gets impaired, and it's somewhat throttles back. And as a compensatory result of that, the AMP kinase is activated. Now,
Yes.
normally when the AMP kinase is activated, that's a good thing. I mean, especially with a ketogenic diet, we want to suppress mTOR, we want to increase AMPK. So why is it a bad result here? Just it's a bit confusing to me.
Okay, AMPK was, so to speak, designed over 2 billion years to handle what I would call the natural environment. What is our natural environment? It is essentially the regular inflow of chemicals that we call food, and how we handle these sugars and these nutrients in the body. And essentially, AMPK is able to turn on and off all sorts of processes within the cell.
Mm-hmm.
When you uh, inject an agent that has no chemical support whatsoever, and that can come about in a completely unpredictable fashion because you're close to a printer
Mm-hmm.
or because you're close to a cell phone, this
Mm-hmm.
is something that the enzyme has never been programmed to do. If we
Mm-hmm.
spend another billion years in this type of
Sure.
environment, it will change. But the enzyme doesn't know how to handle this. And if you essentially destabilize the fine regulation that this
Mm-hmm.
enzyme has established, you will have a an imbalance between oxidative phosphorylation and glycolysis, which is, and this balance is important in cancer, it's
Mm-hmm.
vital in diabetes, and by the way, magnetic fields can stimulate some of the effects of drugs like metformin that are very,
Mm-hmm.
very close to diabetes. So the link between the two is very, very easy to make.
Okay, so it's an imbalance in the very delicate, sensitive feedback mechanism that's the key. Because as I said, normally increased levels of AMPK are considered beneficial. You want to activate AMPK, you want to suppress mTOR, but if you're just got your foot to the metal and it's just going high continuously, that's not a good thing because it needs to have this fine-tuned control, which you lose or lose at least partially when you're exposed to the EMF, electromagnetic fields.
Yes, that's a good description. In other words, if you challenge important regulatory mechanisms of cells,
Mm-hmm.
some things that are nefarious will come out. And
Mm-hmm.
reducing the amount of ATP by itself, even not considering the regulation, is also something that is damaging to the cell because so much of the biota is dependent. Like, take reproduction, for example. Our sperm
Mm-hmm.
counts are going down,
Mm-hmm.
you know,
Well
and
documented, 50%.
they don't know why, apparently. Well, if you look at certain literature, you find that magnetic fields are able to do that at the level of 160 nanotesla, very, very
Mm-hmm.
convincingly. So essentially, with these fields, we are reducing the available ATP, but we can
Mm-hmm.
survive that. The amount of ATP in our brains determines our intelligence. So we
Mm-hmm.
become a little bit less smart. We become a little less fertile. With the NTP studies that are coming out, the National Toxicology Program, we're also creating brain tumors. What
Mm-hmm.
else would we like to do? Add diabetes, and was this a good idea? Electromagnetic fields should be confined, and the natural environment is what biological systems are used to handling. You
Yeah.
change that in a drastic way for the pleasure of industry, and there will be consequences.
All right, well, let's jump back to your research. As far as I can tell, most of your research was done on cells, in vitro studies.
That's right.
So you haven't really expanded it yet to clinical evaluations, and I'm not even sure how you would, but I'm sure you're a pretty creative guy. You can come up with some designs. But is there any do you have any plans of doing that, or has anyone else looked at and tried to validate your mechanism in a at least in an animal model, if not a human?
Uh, Depending on the, I would say, the mechanism that you're studying, human experiments can be necessary or not. In some cases, they are very, very critical. But when you're talking about a mechanism such as this one, in other words, impairing the basic metabolism of a cell, I'm not very attractive to going into these costly studies. What I am doing currently is that I am trying to design a technique by which we could kill cancer cells using magnetic fields. And so
Interesting.
if I can do this in vitro in a powerful way, then this should be transferable fairly easily in animals if I can reproduce the exact. And in the past, I can tell you, we were able to kill cancer cells within 1 day or two, simply
Wow.
by selecting the correct magnetic field.
All right, you'll have to elaborate on that because that's very intriguing. I didn't even realize that was part of your research. So, how are you doing this? Is this a customized magnetic field that you determine based on some individual cellular characteristics, or is it sort of a generic protocol that you're using?
It is something that should work on most cells. We have tested this ability to suppress metabolism in cancer cells in at least 2 cancer cells. And I feel that if we go to other cancer cells, it would still work. But of course, in order to produce enough data to convince a very, very skeptical audience that is huge in relation to cancer, you have to have a lot to offer. And when you have no funding, this takes a very long time. So you understand that I cannot deliver to you certainty or an exact technique, but we are working on this technique and we are optimistic.
So, can you disclose what the technique is, or is that proprietary? Or
what it is that if you look at cancer cells, they have one characteristic that is very peculiar. And one of them is that they have crests of demand for ATP that are very, very high. So at a certain point in time, they will need a lot. So if you have the ability to suppress ATP synthase, which probably produces between 80 and 90% of the ATP in a cell, this cancer cell is not going to do very, very well. And if you add a little bit of glycolytic suppression in there, this cell will have practically nowhere to go.
All right, I understand the process now. So, but before we delve deeper into the process, where does the other 10 or 20% of the ATP come from if it's not being generated by ATP synthase?
From glycolysis. In other words, the cell outside mitochondria does generate small amounts of ATP. It's just that they are not a big part of the budget.
Okay. All right. So getting back here to your proposed cancer approach, it seems like it's an alternative, and a far safer alternative to ionizing radiation, or radiotherapy that is frequently being used. So you'd have to target this to the actually cancerous tumors. It's not. It doesn't sound like it's something that could be used systemically, because you wouldn't want to shut down the ATP synthase of non-cancerous cells.
Well, it depends on how motivated you are. I did tell you, and I did measure already, that in some cancer cell lines, the requirements of ATP are very, very high. In some other cancers, they're not quite as high. And I'm talking about the crests of ATP need. So if you apply this systemically, you would have a larger effect on the cancer cells than you would have on normal cells that don't present these crests of ATP consumption. But you have to, so this could be done either as a uniform field all over the body, but it also could be focused, because magnetic fields can be geometrically shaped to have certain values in certain locations.
And what type of fields are you talking about? Are they static fields, and are they really high fields? Like, you know,
They are not high fields. At the moment, we're using lower frequency fields to achieve this.
and is it static or is it a pulse frequency?
No, those are static fields, and they're applied
Okay.
over long periods of time. So in other words, we're
Oh,
talking
okay.
about days. We're not talking about very short exposures.
Very interesting. Do you have any initial data that you haven't published yet?
Of course, I have initial data, but it's not published yet because I don't want to publish it yet.
Okay.
This is
But it looks
going to turn out to be a very expensive interview if I continue.
All right, I won't press you for that, but it looks promising. Would that be a fair assessment?
Yes. The thing is that I can tell you, I think that's not a very big secret. I applied for funding for this to the Canadian Cancer Society in what is called their innovation program. In other words, this is a program that is supposed to um, to promote new initiatives that are not classic initiatives. And that year there were 28 applications, and my application came in 28th.
Congratulations.
Thank you very much. So obviously this that did not get funded. You can't imagine how difficult it is to go to a bunch of oncologists and say, we're going to cure cancer without touching the patient, without giving him a drug, with magnetic fields. You know, there's a whole cultural gulf, you know, a huge gulf of culture to breach.
I would agree. It's definitely a big hurdle to overcome, and I wish you luck in doing that because you know, they don't. Very few scientists really appreciate physics unless they're physicists like you. So it's just it's a very challenging discipline. In my view, probably one of the most challenging scientific disciplines there are, physics and math. So getting back to the magnetic fields, though, not so much on the cancer therapy approach, which is exciting, and I thank you for sharing that, but on a preventive approach, because it sounds really, you know, your research, I mean, you're showing effects at about 4 nanotesla, which is like 0.04 milligauss. I mean, which is like most people hardly, unless they're outside, you know, you're never going to see that because it's, I've rarely ever seen it that low in a house or a building. It just doesn't go that low. So I mean, this is essentially what people are exposed to indoors all the time. So you're seeing these effects. So what are the practical implications of knowing the damage is occurring, that we're suppressing ATP synthase by exposing ourselves to our field? I mean, what can we do to mitigate against the problem or the potential damage?
Well, I think that the damage is serious to cells and is extensive. I believe, like Milham does, that the cancer rates have been influenced chronically by these exposures. And what you can do to protect yourself is that even in a very conventional way, you could look at what the International Agency for Research on Cancer says, and they confirm that they find a connection between childhood leukemia and fields of, say, 100 nanotesla. So if you have children underage, make sure that they are not exposed to high magnetic fields a lot of the time. In other words, make sure that their beds are not near a baseboard heater. And if you can, get an inexpensive instrument and make sure that your young children are not at a 3- or 4-fold risk of leukemia because of this uncontrolled agent that we have in our houses.
Yes, indeed. And would it be fair to say that the magnetic fields are typically associated with the electric field, so that if you have an electric cord coming out of your wall or a transformer, I mean, you're going to have pretty high magnetic fields in addition to the electric field. So you want to minimize both.
Yes. The easiest thing, of course, is to make a measurement with the small instruments. They're not expensive. The thing is that assessing sources, like a transformer has a field that is, they attempt to confine the field within the transformer, but the field of a transformer usually goes down as 1 over distance cube, which is fairly rapid. Whereas a fluorescent light, which is a linear source, goes 1 over distance squared. And
Mhm.
so depending on the type of source that you have, it's fairly complex to calculate because you have so many wires around you. But
Yeah, well, that's not been my observation. That's what the theory is. But let me just translate that transformers are also called charging devices. So if you're going to charge your cell phone, as almost everyone does, it's the rare individual who doesn't, and you plug that cell phone charger into the wall, I don't think I've ever seen a grounded cell phone charger. They're all 2 prongs, so they're not grounded, which massively worsens the field. And most of them are several hundred volts per meter, and that doesn't go down to relatively safe levels until you're a yard, 3 feet away, 3 feet before it goes down below 10 volts per meter.
oh, I was talking about power utility transformers, not the ones.
Oh, okay. Sorry, we had a miscommunication there. Because
That's
when
right.
I think of transformers, most of us are not exposed to those transformers. I mean, a few of us are foolish enough not to appreciate the danger, but we're all exposed to the transformers. Probably everyone watching this has 10, 20, 40, even 50 of them in their house.
That's true. And those transformers are made to be very, very compact. They don't have any shielding to make them very, very light. So essentially, they leak power because for the devices that they are powering, power leakage is not very important.
Mm-hmm.
Compactness is important at that point. So it's an engineering design based on the false information that these
Mm-hmm.
fields spewing into the environment, it doesn't matter. So what you need is a small transformer of that type that outputs a DC signal, which of course does not
Mm-hmm.
oscillate, and that is well shielded or far enough from you. So one simple method is to plug it very, very far and lengthen the wire to the device that you're using.
Well, still stay away from it and make sure your device is in airplane mode and not have Bluetooth activated or Wi-Fi. I mean, there's
Oh, I
all
was
the
talking
devil's.
again about a radio rather than the cell
Oh,
phone.
okay.
So if you have a radio, all electronics requires DC anyway. Your computer doesn't want AC. You practically have
Mhm,
nothing in your life that requires AC fields. So in
mhm.
principle, power utilities could distribute DC power everywhere and eliminate this leukemia and this cancer problem entirely. And now,
Yeah, I would
this
agree.
is, this is possible because we have semiconductors who can transform DC from a high DC voltage to a low DC voltage. We didn't have that in the times of Westinghouse.
Mhm. Yeah, so let's expand on that a bit because there's an increasing percentage of the public who is adopting solar energy, which I think is a great transition, a clean source of energy, non-polluting, of course. But the problem is it creates DC energy, and we all pretty much have AC. So you have to have these inverters, and the inverters, in the process of converting that energy, they create dirty electricity, electromagnetic interference, which causes a huge problem. It can be remediated somewhat, but it's a challenge. So why don't you discuss if someone was building a new house and wanted to start from scratch? I mean, is it possible? I mean, I know in some rural areas where electricity isn't an option that they have these options, these alternatives, but you need like a DC refrigerator and all your appliances would have to be DC. So is it technically possible to create a house in the 21st century that just runs on DC?
You will find all sorts of hurdles everywhere because all appliances are using AC power simply because of this trick that was found by Westinghouse that you could transform voltage levels either from high to low or low to high in a very efficient way with transformers. So this trick, which is ingenious, has essentially invaded the whole of industry, and practically everything that we find, except the electronics,
Hmm.
uses as input AC power. So a person who would like to avoid AC fields faces a substantial technical challenge. But you're right. The bringing about of these clean energies, in particular solar energy, could create an incentive to have an electrical network that would be more based on DC, ultimately eliminating AC entirely. There are many advantages to a DC power network. The big problem is that we have been committed for 100 years to
Hmm.
AC installations.
Yes, that's a huge hurdle to overcome. But it is technically possible, it sounds like, from your understanding of the process,
It
to
is, in
do it
fact,
individually.
it's better. It would be more economical, and you would save 20% of the energy budget. This transition could not be made overnight, but
Hmm.
really utilities should start making it now, because in a power industry where you don't rely on huge power stations anymore, the fact that individual producers or individual small sources don't have to synchronize together as they do in AC, they just have to adjust voltage levels, would be a very
Hmm.
substantial advantage. And you wouldn't need
Yeah.
these losses. When you use a computer, you feed it AC power that is transformed to DC. And
Right.
this
Absolutely.
transformation is expensive.
Yeah, there's obviously loss there, and it's the same thing when you're generating the energy from converting it from the sun. You're losing 10, 20% in the conversion process. So I'm also curious. I suspect I know the answer, but I don't. I'd just like you to confirm it. It would seem that if you were using DC as your source and you didn't have the AC, and your electric wires transmitting the power throughout your house were just DC, then there really wouldn't be much electric fields emanating from that. And the concern that that I view as a result of interacting with many building biologists, that the electric fields coming from the wiring in the bedroom at night is one of the most pernicious threats to health, would not be an issue. You wouldn't have to turn off your power at night because there's essentially wouldn't be much of a field there. Is that correct?
The thing is that the static fields are not really biologically active, and the reason why they're not
Ah.
biologically active is that the Earth has a static magnetic field of 50 microtesla,
Hmm.
500 milligauss, which has been there forever.
Hmm.
And we have outside an electric field, static, that varies very, very slowly according to the weather and whether there's a thunderstorm. But it's not something that varies 60 times per second. So
Hmm.
essentially, DC fields are biologically acceptable because our environment is made with them.
Okay, good. And just to go back to your cancer research, those are not static fields; those are pulsed fields.
Those are
Okay.
AC
All right.
fields that I'm using.
Okay.
Yeah.
All right. Good. So yeah. So because otherwise it wouldn't make sense. Okay. So it's pulsed fields has some new exciting innovations. That was a nice pearl out of this interview that I wasn't expecting.
Yes. Well, you know probably that pulsed fields have a power that is specific to them, because
Mhm.
we know for uh, the regeneration of bone, for example, that
Mhm.
pulse magnetic fields have been
Sure.
used very successfully. And we know that from cell phones, we do get these pulses of radiation that are very effective at creating effects in electrosensitive people, and are also very effective at increasing the rate of diabetes in populations. So
Sure.
these small fields have virtues of their own as well.
So, and these are called PEMF devices, and there's a large number of them on the market. And the therapy that's emanating from them, is it both electrical and magnetic pulses, or is it just primarily magnetic?
There have been two versions of this. Originally, the first people who looked for biological stimulation were using electric fields. But magnetic fields have substantial advantages because they penetrate the body fairly easily compared to electric
Mm.
fields. So
Okay.
slowly, researchers gravitated to using, you know, sort of magnetic fields. You have the same thing now in very, very trendy new developments where people inject intracranially DC fields into their brains. You can do the same thing with magnetic fields. So there's a great deal of commonality in terms of the means, either electric or magnetic fields, to induce currents in the body. They amount to the same thing if they're done in the same with the same intent.
And the therapeutic PEMF devices, these are alternating, switching 60 hertz,
Usually,
or
those are yes,
okay.
they're designed to enrich in bandwidth the signal that is going into the biological system, because they're meant to alert, so to speak, biological systems that a change is needed. So
Okay.
having pulses creates a wide bandwidth that solicits a lot of biological systems simultaneously.
Okay, great. Well, this is a lot of exciting information. We got more than we bargained for with inviting you to dialogue. But it's really exciting, and I think ultimately the end result is, of course, what we know all along, is that there's certainly some potentially useful research that you're going to come up with, but we know now, I mean, the research, there's thousands and thousands of studies that have been published and mostly suppressed, that it is dangerous to be exposed to conventional EMF fields. I mean, there's just no question. So we need to lower our exposure as much as possible. And, the devil's in the details, and it really takes a significant commitment. You can't do this frivolously, and you have to understand that the danger is there. And in my experience, being naive and thought that I understood this, and I was foolish, but I didn't really get it until I actually picked up a device to measure it, and I could actually discern the field, because you can't feel these fields. I mean, most people can. 3% of the people can. We're electromagnetically hypersensitive, but most of us can't. And because we can't see, hear, or feel it, we just don't think it's causing a problem. It's just the same way that ionizing radiation, the gamma rays or X-rays, we wouldn't feel until it was too late and we were dying or dead.
That's right.
So
We have lost the ability. Sharks, are very electrosensitive. When a shark bites you at the last moment, he's being guided by electric fields around you, and he's not guided by his eyes anymore. And most primitive animals had an electric sense. It's just something that we have lost to the profit of something else.
Yeah, I mean, we've gained other advantages, but that's certainly one that we lost too. So, I mean, it's the devil's in the details, and I really thank you for your research. Are there any closing comments or points you'd like to emphasize before we sign off?
Well, the job that we all have to do is to protect ourselves, and perhaps, even more, to convince the engineers to protect us, because they are the ones producing the devices. So ultimately, we will have to convince them and the standard bearers that these fields are dangerous. Otherwise, it will always be an individual effort, which will be very, very difficult to sustain.
Well, fortunately, I can play a process in that, and there's an electrical engineer, Alistair Phillips, who runs Power UK in England, and I'm UK. You might be familiar with him, and he's actually in the process, based on my prompting, to contact a number of companies that make these transformers, because it is like virtually impossible to find a plug-in transformer, not an electrical power utility one, but a plug-in transformer to power your cell phone or your computer, to find a grounded, shielded transformer. They just don't make them anymore, and they're switching. So we can go back to the old ones, and if there's a demand for it, as I hope to create, then the companies will produce them. And it's kind of a selfish motive, because I want them, and we can't afford to make them ourselves, but these big companies can do it. And if there's a market for it and people are willing to pay for it because they know it can cause harm to them, and that if you can find a safer alternative, then there's a demand for it, and then they'll make them. So it's just a matter of creating awareness among the public.
They should be in a green rather than a black box.
I like that. That's really good. That's really good. Yeah, a green instead of a black box. That is really brilliant. Thank you very much. Well, and thank you for all your research. This has been a real delight to connect with, a solid researcher like you who's got some novel ideas and is making some big headway out there, and really have the courage to go on your convictions and really explore the details independently, because most researchers don't do what you're doing. I mean, you're creating a target on your back, and it's my hats off to you for your courage to do that, and the tenacity to continue with your efforts, because you're certainly going upstream.
Thank you very much.
Thanks so much for watching. Remember, hit the like and subscribe button so you can get more videos that can help you and your family take control of your health.